In this example, we have to solve the equation 3 to the power of x equals 9 to the power of 5. This is called an exponential equation because we have an exponential term, 3 to the x, set equal to another number. Okay, so 9 to the power of 5 in this case. Now, some exponential equations that we're going to see later on, we need to use a mathematical concept called logarithms to solve them. But in these early exponential equations, we're just going to use a little piece of trickery. And the reason that we can do this is because both 9 and 3 can be written as powers of the same number. Both of them, both 3 and 9, can both be written as powers of 3. And that's the condition that we're looking for to allow us to do these. So both these bases, 3 and 9 are called the bases. Both bases must be able to be written as powers of a single number. Okay, so what we're going to do is write both 3 and 9 as powers of 3. Now, 3 we don't really need to touch. If you want to, you can say 3 is the same as 3 to the power of 1. And you can say 9 is the same as 3 to the power of 2. So our job, first of all, is to check, can we write 3 and 9 as powers of the same number? In this case, we can. We can write both of them as powers of 3. So let's replace the 3. Okay, we're going to replace that 3 with 3 to the power of 1. And that's raised to the power of x. And we're going to replace the 9 with 3 squared. So 3 squared, and the 9 was to the power of 5, so that's to the power of 5. Okay, now we use the rules of logs. This is 3, you've got an inside power and an outside power. Sorry, we're going to use the rules of exponents, not logs. 1 times x is x, and here we have a 3, and the inside power is 2, the outside power is 5. 2 times 5 is 10. So when you have an inside power and an outside power, you multiply them. Now, at this point, what you can see is that the bases on each side of the equation are the same. Base 3 on the left, base 3 on the right of the equal sign. So if the bases are the same, and the entire terms are the same, then the exponents must be the same as well. And that tells you that the exponent on the left, x, has to be equal to the exponent on the right, 10. And that's it. X equals 10. Okay? So the idea, the basis behind it, is that you replace both bases with as powers of the same base. Okay, so write 3 as 3 to the power of 1, 9 as 3 to the power of 2. Once you do that, and you simplify the exponents, the answer comes out pretty quickly.